Now, in the video that we explained the theory of hybridization here, we talked about an instance or two instances where we had unhybridized p orbitals. So in the sp2, if you look here, we had pz was unhybridized, and in sp we had two p orbitals that were unhybridized. Well, that brings us to the next topic, which goes together with hybridization. So you end up with two types of bonds. The first one is called a sigma bond, and a sigma bond is the simple traditional bond where you have the overlap between the two orbitals on, of course, two different atoms, as you see in this case right here. So again, this right here is called a sigma bond, and of course, the Greek letter that looks like a 6, that's sigma. However, when you have unhybridized p orbitals, just remember, if we have a p orbital that is unhybridized, and I'm drawing this, I'm going to use different color for the sigma bonds. So this is your sigma bond right here. But be aware that the unhybridized p orbitals also have electrons. And those electrons are not happy. They need to pair. So they need to form a bond. Well, there's a way for them to form a bond. However, it's going to form a weaker bond because the overlap is weaker. So we said that this was a sigma bond, but then these electrons in the unhybridized p orbitals have to find a way to form a bond. Well, this bond, okay, that is called, it's a second type of bond that results from the overlap between two p orbitals oriented perpendicularly. So if you see, this is perpendicular, okay, to the p orbitals are perpendicular to the sigma bond. These result also in an overlap, and this overlap is called a pi bond, a pi bond, a pi bond. Here it is, a pi bond. Okay, I drew it too close here. So again, a pi bond is the overlap above and below the sigma bond axis. Well, let's look at an example using graphics here, because no matter how hard I would draw this, graphics are going to simply give you a better, much better picture. So if you look here, if you remember when you had an sp2, that tells us that we have a p orbital that is unhybridized. Well, here it is, the unhybridized p orbital. So when they come together, notice that they actually end up forming an overlap above and below. Here's your sigma bond, and that now is your pi bond. So again, there's an overlap, but it's a weaker overlap. Overall, what are we looking for? Well, we're looking for also a quick way of determining the number of sigma bonds. However, graphically, we should be able to do. So again, we're going to have any questions so we can explain how these drawings can actually, you can actually draw them. But to find the number of sigma bonds and pi bonds, use the following table. If you have a single bond, that's simply a sigma bond. However, when you have a double bond, now you have a sigma bond and a pi bond. If you have a triple bond, that's a sigma and two pi bonds. Okay, so let's look at a simple example here. Okay, so suppose we have this structure right here, and we would like to determine the number of sigma and pi bonds. Well, we're going to start with the easy ones. All single bonds are sigma bonds, and even a double bond has a sigma bond. Okay, so we have a sigma here, sigma, that's 2, it's 3, 4, 5, 6, 7, 8, 9, 10, and also there's one here. There's one sigma in there too. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 sigma bonds. And what about the pi bonds? Well, there's a pi bond only when you have a double or triple bond. So do we have a double bond? Yes, we do. So that's a double bond, and the double bond has only one pi bond. So in this case, we only have one pi bond.